So for the majority of growers, their ultimate outcome is that 100% of their vineyard is productive and their vines are operating and producing maximum yields and the fruit quality is as good as it can be. So missing vines and bare wire represent areas of lost opportunity. Like over here, if we transition from this vine into this space here, you can see clearly that we've got missing vines and the coverage of vines leading across the trellis wire is declining. So the ultimate question that pose is how much of that is occurring through a vineyard, where's it happening, and what's the cause? Is it something that we can do something about? Is it related to nutrition, disease, soil type, irrigation, or a number of other factors?
Okay, well, I'm just going to demonstrate how some of our precision drone mapping technology can be used to map bare wire in the vineyard. So on my screen here we have a view of vineyard from one of our lovely premium wine regions in South Australia. And looking over it, we can see here there's an area where the vines are being cut back and retrained, potentially due to disease or something like that. But in this area here, we've got some quite obvious gaps in the canopy. So we can see that from a wide angle, and the grower obviously knows they're there as well. But we're really keen to try and quantify that for them in an automated way so we can give them hard numbers about how much wire is actually not being productive for them. So if we zoom into that area there, we can see, again up close, there's probably 3 or 4 vines missing here. I think they've planted one, hoping to regrow here, and there's a few other gaps in the canopy throughout. So what we can do then is we can create a mask, which basically means the white pixels are what we now consider grapevine canopy, and the black pixels are not. We draw our rows on, so these are the basically where the trellis wires will be running down the rows, and we can see very clearly that there's a large extent of the row here, the row wire here, that has no canopy on it, and other gaps in the canopy that we looked at in the image before come out really strongly in this mask. And so once it's like this, it's very easy for us to quantify exactly how much missing canopy there is. This image is at about 3 centimeters, 2.9 centimeters resolution, so we're actually making a measurement for every 3 centimeters of trellis wire. The other thing we can do is go to a vine where the canopy is much smaller, so obviously that part of the vine is struggling, potentially it's just the ends of the vine starting to meet between the two, and we can do the same metric here, and we can apply a mask and see that this part of the vine is really narrow. So potentially the grower isn't just interested in where there is bare wire and where there is canopy, they're potentially interested in where there is bare wire and small canopy versus where there is big canopy. And so again, putting the row line on there, we can see that we could quite easily go along here and say, cool, every part of the vine along the row that's less than, say, 15 centimeters wide, just consider that bare wire, and then we can give them a metric based on how much of the vine, how much of each row is less than 15 centimeters wide. So there's a couple of really cool things we can do there. And those things will all end up in our grower portal, our online website, which is a link to a database which contains all the imagery we've flown, along with all the results that we've computed for it. So we can see here we've got a histogram showing the distribution of vine canopy areas for this block. And we've even, we can select them by the small ones here. So these purple dots here are the smallest vines, and up to 0.78 square meters, we've got 97 vines there. So we can actually use this tool already to count and quantify how many vines are below a certain threshold of area, or too big for a certain area, to have a area that's too big for what they're after. So yeah, those tools are there and they're getting built on every day.